During last lecture, we have completed the topic with numericals, that is the second law of thermodynamics. Today we start new topic, that is topic number 4, that is entropy. Entropy. So what is this entropy? So entropy is a extensive property of thermodynamic system. So that means this is a one property. So we know that while studying the first law of thermodynamics, we found one property, and name of that property is internal energy. So that means when first law is applied for the process, we found that property and given a name as internal energy. In the same way, when we apply second law of thermodynamics to the property, so thermodynamic process, then it will give us one property, and the name of that property is entropy. So it is an extensive property. So, for example, we know that there are so many thermodynamic properties like pressure, volume, temperature, enthalpy, internal energy. Already we have proved that are the point functions which are the properties. Internal energy also we have proved it is a property. So we know that the properties are measurable properties and unmeasurable properties. So this entropy is unmeasurable property. So that means what? We know temperature. So temperature is one of the property of thermodynamic system. Similarly, entropy is also property. We know that temperature is measured with the help of different temperature measuring instruments. In the same way, we also measure the pressure, value. These are measured with the help of some of the instruments. So instruments are available to measure these properties. But for example, you take an example of enthalpy. Enthalpy is also one of the property. So we know that enthalpy H or delta H change in enthalpy is given by Cp dt. So that means there is no any instrument. There is no any instrument to measure this enthalpy. But we can calculate the enthalpy with the help of these measurable properties. So pressure and temperature are the measurable properties. So that means this enthalpy is a measurable property. But it is expressed in terms of measurable properties. Similarly, this entropy is unmeasurable property. There is no any instrument to measure this property entropy, but it is expressed in terms of ds is equal to dq by dt. Okay, so this is something about this entropy. Now, why it is necessary to study this entropy, or what is entropy? Regarding this entropy, already I told you that when we apply first law of process, the existence of internal energy as property was found. I already told you. Similarly, when second law is applied to thermodynamic process, the new property was found and known as entropy. Then it is a few other important points as far as important points which you have to keep in mind studying this entropy was, first point, it is an extensive property of system. Entropy is an extensive property of the system which increases. So just now I showed that ds is equal to dq by dt. So this entropy is extensive property which increases when heat is added to the system. increasing and decreases when heat is rejected from the system. Can you understand? Entropy is extensive property which increases with the addition of the heat and decreases with decreasing heat. Then second point which we have to keep in mind. As a matter of fact, it is a tedious to define the term entropy. So entropy is denoted by the capital letter S. So it is very difficult or tedious to define this term entropy. But it is very easy to define the change in entropy, ds. Instead of this S, it is very easy to ds, or we should make sure this as a ds. Change in entropy. Okay? So as a matter of fact, it is a tedious to define the term entropy, but it is comparatively easy to define change of entropy of working substance. Now working substance, already we have studied hydropower plant, water power plant, refrigeration. So there the medium which is used to achieve the changes, the substance which is there is known as the working substance. So once again we return. First point already clear. Second point, as a matter of fact, it is tedious to define the term entropy, but it is comparatively easy to define change of entropy of a working substance. So this is something about the second point, most important of this entropy. Third point, in a reversible process. So already we know what is a reversible process, what is irreversible process. In actual practice, there is no any process reversible. All processes are irreversible processes. And in a reversible process, over a small range of temperature. In a reversible process, over a small range of temperature, the increase or decrease of entropy, when multiplied by absolute temperature, gives us heat absorbed or rejected by the working substance. So this is also important. So we just know ds is equal to dq by t. So therefore dq is equal to ds into t. So that means in a reversible process over a small range of temperature, the increase or decrease of entropy, when or the change in entropy, when multiplied by absolute temperature, gives us the heat absorbed or rejected by working substance. So this is ds is equal to dq by d, or dq is equal to ds by d. Dq is equal to ds into t. Okay? Where ds is change in entropy. Change in entropy. Okay? And dg is also known as ds into t. So what are the units? So this is third one. What is the unit of entropy? So already we have cleared the 3 points regarding this entropy. Now fourth point is, what is the unit of entropy? Unit of entropy. We know ds is equal to dq by d. Therefore, ds is equal to kilojoules per kg. Kilojoules per kg. So this is the unit. But when it is applicable, if it is for 1 kg or per kg, or per unit mass. So this unit, kilojoules per kg, is unit of entropy when it is per kg or for a unit mass. Then what is the unit? So this is the unit of entropy. But if it is you consider for unit per kg, then what is unit? ds is equal to kilojoules per kg d. So this is the unit of the entropy. Is it clear? The next point, most important. fifth point. We know Carnot cycle. We already completed the Carnot cycle. We know Carnot cycle. So what is the efficiency of the Carnot cycle? N Carnot is equal to 1 minus T2 upon T2. Or in our language, 1 minus lowest temperature divided by highest temperature. So 1 minus lowest upon highest temperature. So this is the very easy to keep in mind this expression. Similarly, we have solved the examples of this Carnot cycle. So this is one definition of efficiency. What is the other definition? Similarly, N Carnot is equal to work done divided by heat supply, or it is equal to W divided by Hs. Therefore, from this, work done is equal to N Carnot into heat supply. Okay? So, work done is equal to efficiency into heat supply. We also know work done. We also know work done is equal to Q added, or we may write work done is equal to heat added minus heat rejected, or we may write as work done is equal to Q added minus Q rejected. So these two expressions for efficiency, from where we can calculate the work done. In the other way, we also calculate work using heat added minus heat rejected. Isn't it? Okay. Therefore, heat rejected. We make sure it as a Q rejected is equal to Q added minus WD. So from this we can calculate Q rejected is equal to Q added minus WD. Okay? Therefore, Q rejected is equal to Q added. So as it is minus N Carnot into Q added, because we have to replace this work done by this N Carnot into heat supply or heat added. Okay, so you may write it here, it is N Carnot into Q added. Okay, therefore Q rejected is equal to Q added 1 minus N Carnot. So this is the simple expression to calculate work done, efficiency, then Q added, Q rejected. Okay. So this is something about this entropy, basic introduction of this entropy. Okay. Now we see one example. So that example, now you see the example. What is given in this example? Simple example. For Carnot cycle, temperature of heat added is 1500 degrees centigrade. 1500 degrees centigrade. And temperature of heat rejected is 300 degrees centigrade. And if heat supplied is 1400 kilojoules. calculate work done and heat rejected. So that means Q temperatures of T2 and T1 are given. Then temperature of heat supplied is given, and it is asked to calculate work done and heat rejected. Okay. So we'll start. We know work done is equal to Q added minus Q rejected. So it is equal to N power is equal to 1 minus lowest upon highest temperature. 1 minus lowest is 30 divided by 150. So it will come efficiency of carbon is equal to 80% or 0.8. So this is the carbon efficiency. Okay. So you see, so just we have completed the formulas, and from by using that formulas we have calculated. Now second part, Q rejected. Q rejected is equal to Q added 1 minus Carnot efficiency. Last expression we have seen Q rejected. Q added is there 1200 minus 1 minus 0.8. It is equal to 40 kilojoules. After calculation, to do the calculation, so Q rejected is equal to 240 kilojoules. Therefore, work done is equal to Q added minus Q rejected. So added 1200 minus 240 is equal to 960 kilojoules of work is done. So the answer which is asked is 1. The answer which we have calculated the heat rejected, we also calculated the work. Okay. Now we know. Again we know. Now we know. ds is equal to dq by t, or s is equal to q by t. Change in entropy or total entropy. Okay. Q added divided by T added is equal to 1200 divided by 1500. It will become 0.8 and it is a ds. So from this, okay, Q added divided by T added. So if you calculate change in entropy, it is 0.8. Okay. Similarly, Q rejected divided by T rejected is equal to 240 divided by 300. It is equal to 0.8. This is a ds. And we know that sign convention for heat added and rejected. Heat added positive, heat rejected negative. So that means out of these two terms, this is a negative. This is a negative. So summation over a cycle is 0. Okay. So what you conclude from this? We always consider from sign convention. We always consider from sign convention of heat added positive, that is given to the system, and heat rejected is a negative, that is taken from the system. Therefore, this first ratio is positive and the second ratio is a negative. Therefore, overall Q by T is equal to Q added divided by T added plus Q rejected divided by T rejected. These two ratios summation 0.8 minus 0.8 this Q by T is equal to 0. So Q by T is nothing but the entropy. So from this we can conclude that the entropy is a property also.